Hi, and welcome to Tom Kennedy Science, and I'm your host, Dr. Tom Kennedy. So as many of you know, climate change is a major threat to our world, both for our civilizations and all of the animals and plants and ecosystems that live here. Now, we need to do something about this. As a society, we need to do something about climate change. Unfortunately, it's difficult to get everybody on board with doing something about something like climate change that they may not believe in. So unfortunately, a lot of our politicians don't believe in climate change or don't think it's a problem, and they represent people that think the same. So how do we change minds? Because there's a lot of evidence out there. Now, if you're like me, I'm a science guy. You got to show me the evidence, and you have to show me that evidence is credible. Don't just show me a pretty chart and graph. Where did that information for that chart and graph come from? And that is important. So my goal today is to describe the evidence of climate change. And of course, I'm assuming that humans are causing this climate change based on evidence, and I'll get more into that in another video. So how do we know it's changing? Now, I talked about where does my evidence come from? A lot of it comes from peer-reviewed journals, from scientists actually doing the work, from data collected by NOAA and NASA. Now, I know some people will go, well, that's just government. I don't trust them. I do. The scientists that work for NASA and NOAA are top-notch, and they are collecting data on our planet that I buy into. And that data is showing that our activities are warming the planet, that we're burning fossil fuels, we're rising carbon dioxide levels, we're clearing forests, and this is causing major changes to our planet. And of course, to me, seeing photos of polar bears on tiny pieces of ice really have come to symbolize our changing world. And we know that carbon dioxide levels are rising. Now, as of May of 2021, carbon dioxide levels are nearing 420 parts per million. Now, that's up from 285 parts per million. And yes, we know that increase in carbon dioxide levels in the atmosphere is from our activities. Our burning of fossil fuels is rising carbon dioxide levels in the atmosphere. And this, of course, is the Keeling graph showing those changes over time. Now, this is important. And in another video, I'll explain how we know that CO2 is coming from us and not from natural sources like volcanism or something. So let's examine some more of this evidence. When we look in the Earth's past, we know that higher surface temperatures are caused by higher CO2 levels. So we have higher CO2 levels today. Are we seeing rising global temperatures? Here's a chart right here. Yes, we can see going back to the 1880s, early 1900s, temperatures were actually lower than normal. And then around the 1940s to the 80s, they were kind of bouncing back and forth between average, a little bit below average, a little above average. And then starting around 1980, surface temperatures began to really take off. And in fact, we haven't had a single month below average since the early 80s. And there's more to this. Okay, so that's 140 years now. This data is coming from NOAA, from thousands of different temperature gauges worldwide, not just one temperature gauge. Do we have other evidence that has been rising? Yes, we have both direct from temperature measurements from a thermometer and indirect. In the late 1990s, a climatologist named Michael Mann was interested in reconstructing the climate of North America going back about 1,000 years. And the idea was, did some type of warming event cause a loss of people in the Southwest, like all the Anasazi, they just kind of disappeared around 1200 AD. And it's been thought that a warm period caused that, which led to prolonged drought. So they looked at tree ring data. You can also use ice cores, you can use sediment samples from lakes. And what he did is he reconstructed the Earth's past going back about 1,000 years. So when you look at this graph, this is what we call the hockey stick model of climate change. And they used hundreds, thousands of tree core data to reconstruct this. There's several things that are important here. You see that the climate did fluctuate a little bit over the last 1,000 years. Now, do you see that line going through the middle of the graph? That's the average temperature from 1961 to 1990. So what that tells you is that that 30-year window of the climate average is already above the entire average temperature or climate going back 1,000 years. Then starting in the 1900s, you see a rapid rise of climate. And then now, this ended in 1998, and it's almost half a degree Celsius, 1 degree Fahrenheit warmer. And we have already, in the last 20 years, doubled that amount of warming we have seen. It's amazing. So there you have it. I mean, we go back to the 1980s. Surface temperatures have been above average every single year. Not just every single year, every single month. We have not had 1 month globally below average in almost 40 years. Not only that, the warming trend, the rate at which it's getting warmer, is accelerating. And in the last decade, it's been the warmest decade on record. And 2020 effectively tied 2016 as the warmest year on record. And this is also important. You see, 2016 was a big El Nino year. Now, El Nino is a warming in the Pacific. So here is 2020, tied for the warmest year on record, no major El Nino. So we're seeing all the warmest years have been the last 5 years. The warmest decade was the last decade, and we're getting hotter quicker. More information here. You're getting warmer. You're going to have less sea ice. The cryosphere is part of the Earth that is frozen. So it includes things like glaciers, Antarctica, Greenland, the Arctic. The cryosphere is shrinking. We're seeing that in the loss of Arctic sea ice. Okay, it's been declining since the 1979 when we put up a satellite to watch it. Okay, I can't help myself here. People love to cherry pick data. If you want to cherry pick data, you can look at the small little window and say, oh wow, sea ice nearly recovered. Well, let's take a look at the rest of it, right? I mean, the general trend is we're losing sea ice rapidly, and we might have ice-free summers in the next decade or so. And of course, here we are in 2021. We're already below the record set last year. So this is incredible rapid decrease of Arctic sea ice. And here's some older images, but it clearly shows that the loss of sea ice is immense. Now, I mean, we look at these photos and we're like, yeah, that's better than looking at a graph because we don't really have a connection. We don't make some type of, emotional connection to a graph. And sometimes we might make it with a picture. But to show you the extent of that sea ice loss, how many of you have ever driven across Texas on I-10? Right? You're on I-10, you hit Sabine Pass, and you're like El Paso, 900 miles, and you keep driving, and you're driving. Can I please get to New Mexico? I love New Mexico. I don't have anything against Texas, but I want to get to my home state, right? My adopted home state. And if you've ever driven across Texas, it's enormous. That's smaller than the sea ice that's been lost in the Arctic. So that should give you an example of how much ice is lost. Texas is much smaller than Alaska. You can see Alaska next to the ice that's been lost based on that orange line. That's an enormous amount of ice loss. The Arctic is far away. Most of us will never see it. So we don't have a connection to it. We do have connections to our national parks. One is Glacier National Park. They should probably call it the park formerly known as Glacier. I was there in 2004, and you can see that the Shepherd Glacier by 2005 was much smaller than it was almost 100 years ago. So worldwide, we're seeing loss of glaciers. About 90% of them are shrinking. Now, you can grow a glacier if you get more precipitation, and actually a warmer climate can give you more precipitation, more snow. Because if you're 0 degrees and you go up to 20 degrees, you'll get more snow. You're 20 degrees warmer, but you're still freezing. I know, kind of weird, isn't it? I've been to Alaska. This is the Exit Glacier. It's shrinking. I mean, it lost 250 feet in one summer. I need to go back. It's been 9 years since I was up there. I was in there in 2012. I need to go up there probably in the next few years and retake some of the photos in the same places I was previously to document the ice loss in just a decade. ice loss is not limited to the northern hemisphere. Antarctica has been losing ice at an accelerated rate. Now, Antarctica is often in circles of people trying to disprove climate change by saying there's more sea ice than there was 20 years ago. The scientists are all wrong. I will say that Antarctic sea ice often grows, and there's reasons for that. One is there's a circulation pattern around the Antarctic that kind of isolates it from the rest of the world. However, we're back in a trend of Antarctic sea ice decreasing. Now on land, Antarctica is losing ice rapidly, and that's a problem. And there's also ice shelves that are breaking up, which will lead to more rapid ice loss of the Antarctic. And this will also lead to rapid sea level rise. Greenland is also losing ice. It's losing it rapidly. And in fact, this is showing a river on top of the ice, and that melts it quickly. It goes underneath the ice, and no, it doesn't refreeze. It actually forms underground rivers, hoping to melt the glaciers even more quickly, and it lubricates them so they can move faster into the ocean as they melt. And a result of all this melting ice, sea levels are rising. Now, as the Arctic sea ice melts, you won't see much of an increase in ocean rising, and that's because it's already floating. What you do get is a little bit of thermal expansion that will cause the oceans to rise. Now, as Antarctica loses ice and Greenland loses ice, guess what? Sea levels are rising. And this graph is showing sea level rise. And one of the most important things here is that the rate at which sea levels are rising is increasing. So it was 1.2 millimeters a year. Now we're at 4.4 millimeters a year. Now, this much a year doesn't seem like much. In 100 years, that's about half a meter. That's about 1.5 feet. So it doesn't seem like much. How about 1,000 years from now? No, none of us will ever be here. But in 1,000 years from now, you might have sea levels 5-10 feet higher. Well, for our cities, that's a real problem. So our descendants are going to have to deal with this. Not even just our descendants. I mean, people are already having to deal with sea level rise as it is. Just go to Miami and Florida. They're already dealing with it. And they're not the only major city dealing with sea level rise. Don't like a chart and graph? How about this picture I took? This is what sea level rise looks like. Now, you might go, well, that's just the beach eroding. Yeah, beaches erode. That happens. Big storm comes through, changes the coastline a little bit. But when all your coast is eroding, that's a problem. And that's what's happening. Okay, so we're starting to see a trend here, right? We're seeing rise in surface temperatures. We're seeing a loss of the cryosphere. We're seeing a rising ocean. There's other things that are causing it too. Back in the 1990s, scientists said, hey, you know what? If we have a warmer climate, that means the atmosphere has more energy. If you have more energy in your atmosphere and you have a warmer surface temperatures of your oceans, you're going to have bigger storms and more of them. And of course, there's been storms like Sandy, Harvey, Katrina, and keep going on and on here, right? I mean, we're seeing this increase in extreme weather and hurricanes where we haven't had them. And then 2020, a year of records. Let's take a look here. By November 16th, there have been 30 named storms. That was a record number of storms. Hurricane Iota, the 30th storm of the year, reached Category 5 status. Category 5, 150 mile an hour winds. That's crazy. The strongest hurricane that late in the season ever. It was also the 5th straight year that we had Category 5 hurricanes, and of course the U.S. experienced a record number of landfalls. That was just last year, guys. So, we predicted back in the 90s more storms. Well, if you've got a warmer ocean, you can potentially have more hurricanes. Now, hurricane formation is complicated because you can get shearing winds out in the Atlantic that will knock down your hurricane formation. But if you don't have those shearing winds from an El Nino, guess what? You're going to get more storms. More evidence here. We're seeing not just more hurricanes, we're seeing more thunderstorms, more tornadoes, much more intense. We're seeing more temperature extremes. Hey, there was this extreme freezing in Texas this year. And you're like, extreme cold, how does global climate change with everybody talking about warming lead to incredible cold fronts coming through? Well, you know what? It's called the polar vortex. When there's a strong gradient, a big temperature change between, like the US and the poles, you get a strong polar vortex going up there, which holds all that cold air in. As you lessen that gradient, that cold air is more easily spilled out in North America and into Europe as well. Now, you might be 20 degrees above normal in the Arctic, right? But hey, 0 degrees is still cold for us. So that 0 degree Arctic air spills down in here and we have record cold. And guess what? That record cold is caused by climate change. I know it's so counterintuitive sometimes. We're seeing, of course, record heat waves. We see record heat waves that lead to both drought, because as you increase surface temperature, you also increase the rate of evaporation. And if you're having more storms, those storms might not come every day. They might come once every 2 or 3 weeks, dump a lot of rain, it runs off, you dry out, you have more wildfire. So we have seen massive wildfires, massive drought, it's just getting bad. I mean, yeah, all of these things. We're having record wildfire in the West, and we're also now in like exceptional drought as well. And of course, we're seeing like in 2015, 2016, we saw massive El Nino. But that was 5 years ago, Yeah. So there is an overwhelming amount of evidence that we are changing our climate. I mean, we've got surface temperatures. We've got rising sea levels. We measure that independently through multiple thousands of different temperature gauges and satellite data. They are all converging on the same thing. We're seeing the loss of cryosphere. We're seeing an increase in storm activity and extreme weather. This is exactly what we would expect in a period of global climate change as we go from one stable climate to another one, which will be warmer, that might have some more extreme weather along the way. So, like I said, I hope that you look at this evidence and are like, wow, there's a lot of evidence that our climate is changing. And in fact, the evidence is overwhelming. We say that climate change is actually a fact because it meets the criteria of a fact. We can observe it. We can test for it. And we can independently verify through observations that indeed we are changing our climate. We're not just warming it. We are altering the patterns of our rain, drought, and severe weather as well. Okay, in my next episode, stay tuned because I'm going to discuss how we know humans are causing climate change, where I will examine all the natural causes of climate and disprove them and show that the only thing left, of course, is humans causing it. Okay, until next time.